Hi everyone, Assalamualaikum. In this section, we will discuss applications of differentiation, which is graph of polynomial functions, right? What is a polynomial function? A polynomial function is a function which involves only non-negative integer powers or only positive integer exponent of a variable. A polynomial function is defined by its degree. The degree of a polynomial with one variable is the largest exponent of that variable, right? The most common types of polynomial functions are constant, which is degree 0, for example 7, okay? And then linear, okay? Linear is degree 1, okay? For example, 2x minus 3. And then quadratic. Quadratic has degree 2. Okay, for example, x squared minus 2x plus 1. And then cubic. Okay, cubic has degree 3. For example, 2x cubed plus x squared minus 1. And quartic. Quartic has degree 4. For example, x to the power of 4 minus 3x plus 2. Right? Now, let me check whether this function is polynomial or not. Let's say we have 2x cubed minus x squared plus 3x minus 1. Right? This is a polynomial function because it contains only non-negative integer powers. Okay? Here. Okay? But for 3x to the power of negative 2 and 2 over x plus 1, these are not polynomial function because it contains negative powers. Alright? And for this syllabus, we are focused on cubic and sometimes quartic function. Alright? Alright, to understand the graph of polynomial function with degree 3 and 4, let me look at this graph. Right? We have y-axis, x-axis, and origin. And then let's say we have this curve y equals to fx. And then we have this point, okay? And this is called x-intercept, okay? And it happened when y equals to 0. Okay, all x-intercept located on x-axis, right? And then look at this point, okay? This point is called y-intercept. And y-intercept happen when x equals to 0. Okay, all intercepts located on y-axis, right? And look at this line, okay? This line is uphill, okay? This is called increasing, okay? And this is also uphill. And this is also called increasing, right? Increasing happen when the slope or gradient or m or first derivative has positive value or greater than 0, okay? And look at this line. This line is downhill. This is called decreasing. Okay? Decreasing happen when the slope or gradient or the first derivative has negative value or less than 0. Okay? And this is maximum point. Okay? Maximum point happen when the first derivative change from positive value to negative value, or in other words, when the slope change from increasing to decreasing, right? This is called minimum point, okay? Minimum point happen when the first derivative change from negative value to positive value, or in other words, when the slope change from decreasing to increasing, right? And this is called concave up. Okay, concave up happen when the second derivative has positive value. Okay, this is called concave down. Okay, concave down happen when the second derivative has negative value or less than 0. Okay. Okay, let's say the concavity change from down to up. Okay, and then we have one point here. Okay, here. Okay, this is called inflection point. Okay, inflection point happen when the concavity change from up to down or from down to up. Okay. Alright, now let's look at all the important points for the graph of polynomial function. Alright. Polynomial function has three types of critical points: maximum points, minimum points, and inflection points. Okay. Now we consider this graph. Okay, we have curve y equals to fx. Okay, this is maximum point. Okay, this is minimum point. Okay, and this is inflection point. Okay. Critical points, also known as stationary points or turning points. It is any point where the derivative is equals to 0. All relative extrema means maximum and minimum points are critical points. Okay. To find maximum point, we need to equate f prime x equals to 0. Okay. And same goes to minimum point. Okay. An extremum or extreme value of a function is a point at which a maximum or minimum value of the function is obtained in some interval. Okay. An inflection point is where a curve changes from concave downward to concave upward or vice versa. Okay, this is inflection point. Okay, change from concave down to concave up. Okay, or change from concave up to concave down. Okay. To sketch a graph of polynomial function for degree 3 and 4, let's start by finding the x and y intercepts. Okay. Now we consider this graph. Okay. These are x-intercepts. Okay. X-intercept happen when y equals to 0. All x-intercepts must on the x-axis. Okay. This is y-intercept. Okay. Y-intercept happen when x equals to 0. Okay. All y-intercept must on y-axis. Right? Alright, number 2, finding critical or stationary or turning point. Okay. Critical points is any point where the derivative is equals to 0. All relative extrema are critical points. Okay. We consider this graph. This is maximum point. This is minimum point. Maximum point and minimum points are critical points. Okay. To find the critical points, first step we need to find f prime x or the first derivative. And then when f single prime x equals to 0, we need to find the values of x. And then to find the values of y, we substitute the values of x obtained above here into y or into fx. Then we write into the form of coordinate, because point here means we need to express into the form of coordinate, right? Alright, from here, substitute the values of x obtained above into y or fx, means we will get the y coordinate, right? But if we substitute the value of x into dy over dx or into f prime x or into the first derivative, we will get a slope or gradient. Okay, so must be careful. Okay. Alright, number 3, finding increasing or decreasing and extremum points. Okay. The first derivative test provides a method for determining whether a point is a local minimum or maximum. If the function is twice differentiable, the second derivative test could also help determine the nature of a critical point. However, if the second derivative has value 0 at the point, then the critical could be either an extremum or an inflection point. Okay. Now we consider this graph. Okay. This is increasing. Okay. This is also increasing. Okay. This is decreasing. Okay. To find the interval where fx is increasing or decreasing, first we need to find f prime x. And then when f prime x equals to 0, we find the value of x. And after that, we need to use table of sign for f prime x based on the values of x obtained above here. Okay? If we get the first derivative has positive value, means it is increasing. And if we get the first derivative has negative value, means it is decreasing. Okay. Okay, here is a maximum point. Okay. And here is a minimum point. Okay. To find the maximum or minimum points, if the graph change from increasing to decreasing, okay, increasing to decreasing, so we get maximum point. Okay. And if the graph change from decreasing to increasing, okay, decreasing to increasing, so we get minimum point. Okay. Alright, number 4, finding concave up or down and inflection points. Okay. We use the same graph. Okay. This is concave up and this is concave down. Okay. And when the concavity change from down to up or from up to down, okay, we have inflection point. Okay, this is inflection point. Alright. To find whether the function is concave up or down, first we need to find the second derivative. Okay, then when the second derivative equals to 0, we find the values of x. After that, we use table of sign for f double prime x based on the values of x obtained when we equate f double prime x equals to 0. Okay, and if we have f double prime positive value, so means it is concave up. Okay, and if we get f double prime negative value, means it is concave down. Okay, and if the graph change from concave down to concave up, so we have inflection point. if the graph change from concave up to concave down, we also get inflection point. Okay, so the inflection point is when the graph change either from down to up, okay, or from up to down. Alright. Alright, here are some possible shape for the graph of polynomial function. Okay, the first one are the graph of polynomial function with maximum, minimum, and inflection points. Okay, so this graph has maximum point, minimum point, and inflection point. Okay, the second one, the graph of polynomial function with inflection point and maximum point without minimum point. Okay, so these are the graph. Okay. Number 3, the graph of polynomial function with inflection point and minimum points without maximum point. Okay. So this is minimum point and inflection point. Right? Number 4, the graph of polynomial function with inflection point only means there is no maximum and no minimum point. Okay, so these are the shape of the graphs with inflection point only. Okay, and number 5, the graph of polynomial function with maximum or minimum point only without inflection point. Okay, this is the graph with maximum point only, and this is the graph with minimum point only, right? Coming up next, examples involving the graph of polynomial functions. Thank you for watching. Stay tuned. Bye. Assalamualaikum.